Hey everyone, it's Mike, and just thought I'd take a second here to talk about my home energy management system that I'm building and how I'm using the PowerCost monitor from BlueLine Innovations as a key part of that system. So if you haven't seen the PowerCost system, it consists of a reader that goes on your smart power meter. There's an infrared sensor here that reads the pulse that's coming from the meter, and then there's a radio that transmits it to the Wi-Fi gateway. And my energy management system ties into that gateway to gather the information that it needs.
Meet Iggy, my home-built energy management system. I built my own system because I wanted something that gives me lots of real-time information in a format that makes sense to me. With other systems, I had difficulty translating kilowatt hours into anything useful. Iggy converts everything into dollars and cents. And living in Florida as I do, a major portion of our monthly expenses come from trying to cool our houses. So Iggy pays special attention to heating and cooling information. I built highly precise indoor and outdoor temperature sensors. I track the high and the low, and I also track humidity for each day. This allows me to precisely correlate indoor and outdoor temps to cooling costs. I've also built sensors that attach to my AC system to tell me if it's running properly, something no smart thermostat or any other residential home energy management system can currently do. I'll talk about this more in a minute. Of course, I'm using the PowerCost monitor to read the data from my electric meter. I can see the high, the low, and the current kilowatt usage for the day. Iggy also continuously monitors the kilowatt hour usage from the AC system. My system uses anywhere from 2.3 kilowatt hours to 2.9 kilowatt hours depending on outside temp. If the utilization falls outside those parameters, then I know my AC system isn't working properly. Now, if we look down towards the bottom of the screen, we'll see where Iggy ties everything together. It tracks daily energy usage in dollars and cents and how much of that energy is from the AC system. So, for example, on 5/19, I used 70.91 kilowatt hours of electricity, which cost approximately $8.06. The AC system costs $3.43 of that $8.06 total. This means the AC system comprised almost half of the total energy usage for the day. Using this information, I can set my thermostat to 80 and see how much it will cost me to run the AC. Then the next day I can set it to 81 to see how much I'll save. My goal here is to collect enough information to be able to predict what my AC system will cost to run tomorrow based on the projected outside temp and what I've set the thermostat to. I'm still working on this portion of the project, but once I understand the relationship of outside temp, inside temp to cooling costs, I'll build a smart internet-enabled thermostat that will allow me to automatically make adjustments. Using the PowerCost data, I'm developing power profiles that will let me track the usage of my hot water heater, electric dryer, and stove without actually having to put sensors on each device. So here's what I'm getting from Iggy. So far this month, about 20 days into the month, it looks like I've used about $155 in electricity. Of that, about $65 will be from running my AC. The devices that run pretty much every day, computers, lights, etc., costs me about $73 per month, and my hot water heater, clothes dryer, and stove combined have cost a mere $4.55. Pretty cool, huh? Oh, my refrigerator only uses 265 watt hours at peak. Think maybe 3 old-fashioned light bulbs, and costs about $12.44 per month to run. So I'm not really paying much attention to the cost of my refrigerator. Now, if I want to reduce my electric bill, I don't need to tinker with my hot water heater, my dryer, or my stove. What I need to do is reduce the number of devices I'm running all the time and to tinker with my AC thermostat some. Now, let's go back and look at this section here, the HVAC vent temp. The low temp reading of 58 degrees tells me that my AC system isn't operating at peak efficiency. That number should be between 53 and 54 degrees. As I scroll back through the AC log, I can see where the AC system is working at capacity for far too long. This tells me my AC system isn't functioning efficiently. I've got a repair tech coming out tomorrow, and I'll show him my numbers. Let's take a look at what Iggy looks like while the AC system is running. You'll notice that the HVAC status goes from idle to running. The velocity goes from 0 to 1200, and velocity is just a relative number to give me an idea how much air is flowing through the system. The HVAC vent temp went from the low 80s to the low 60s, and that's the temperature of the air coming out of the vents. Also, we'll notice that the kilowatt hour usage went from 1.4 kilowatt hours to 4.2 kilowatt hours, and that's the effect of the entire HVAC system running, the compressor, the fans, everything. Iggy has a basic data mining feature built in that allows me to scan through usage in order to spot trends and discover useful info. For example, I can look at summary usage for an entire month, or I can drill down and look at individual events. So let's take a look at 5/17, where it's the first day where my AC costs seem a little high. So I can drill down and look at each individual event on 5/17. And I can see here that at noon, my HVAC system started running and ran continuously for 3 hours and 28 minutes. That tells me that my HVAC system can't keep up during the heat of the day. Hopefully my AC repair tech today will be able to remedy this situation.
Well, that pretty much wraps everything up. So, hey, thanks for watching. Please feel free to post any comments below. All right, take care.